The history of the universe dates back about 13.8 billion years. At this point, the entire universe converged to a high density and high temperature point. This point suddenly begins to swell. The universe in which we now exist was born. This moment, called the Big Bang, not just an explosion, it refers to the expansion of space-time. Right after the Big Bang, the universe was extremely hot. Elementary particles such as coke and gluon were moving violently in the state of plasma. This state, it's called aviation gluon plasma. During this period, forget atoms and molecules, the nucleus didn't even exist. As expansion continued, the terrain sank. The gluons were combined to form protons and neutrons. This signifies the creation of basic matter components. Just minutes after the Big Bang, the universe underwent an important process called hidden synthesis. In this process, the appearance and neutrons combined to form helium and trace amounts of lithium. These mitigating elements, a direct product of the Big Bang, it is the basis of matter observed in the universe today. About 380,000 years later, the universe cooled sufficiently. Electrons combined with protons and helium nuclei to form the first atoms. This phenomenon is called a recombinator. At this time, light no longer interacts freely with matter. The universe became transparent. The light from this period. This is the currently observed cosmic microwave background, CMB. It is one of the most important pieces of evidence in support of the Big Bang theory. After the recombination machine, the universe is entering a long dark age. No celestial bodies emitted light during this period. Matter was slowly beginning to gather under the influence of gravity. About 500 million years later, the formation of the first composition marked the end of the Dark Ages. These early configurations are very large. By nuclear fusion reaction, it began to emit light while forming new elements. After the initial configuration emerged, a phenomenon occurred to reionize the surrounding substances. This is called reionization. This process spanned hundreds of millions of years, leading to the foundation of galaxy and stellar formations observed today. Stars then converge on each other by gravity. The first galaxy was formed. Early galaxies were irregularly shaped, but organized over time, it became the shape it has today. It is known that supermassive black holes exist at the center of galaxies. These were highly active in the early universe. It radiated a huge amount of energy by inhaling the surrounding material. One example is a quasar. Quasars are located very far away. It provides important clues about the early growth and evolution of the universe. About 9 billion years ago, the universe's expansion rate abruptly accelerated. The cause of this phenomenon is not yet elucidated, believed to be dark energy. Dark energy is thought to account for about 68% of the total energy of the universe. To find out its true identity, this is one of the most important issues in modern astrophysics. About 4.6 billion years ago, second gas and dust gather. The solar system was formed by condensation by gravity. In this process, the sun was born. A planet was formed around it. The Earth was also born at this time, eventually creating a life-supporting environment. The origin of life on Earth, derived from surviving substances. HOMO elements produced by the initial configuration are released into outer space. It became material for future structures and planets. This cycle continues today, one key process in the universe's evolution. There are various hypotheses about the future of the universe. One is continued expansion, the Big Freeze, where the universe freezes over time. Also, halting expansion and contracting in reverse. Big Crunch, or expansion accelerates until everything splits. Big Rip theory has been suggested. These scenarios are It depends on the nature of dark energy and the mass density of the universe as a whole. We are extremely small beings in the vast universe. Responsibility to disturb one's own role in it and to build the future. By knowing the history of the universe, you will be given an opportunity to reconsider the significance and direction of your existence. Cosmic microwave background radiation. CMB is known as a fossil that preserves traces of the universe immediately after the Big Bang. By analyzing this radiation, deepening our understanding of early universe conditions and structure formation. For instance, CMB temperature fluctuations. It reflects the distribution of the main material of galaxies and galaxy clusters formed later. This analysis, US satellites in the 1990s and OMAP satellites in the 2000s, it has been advanced by the current Planck satellite. The universe's evolution. There are many phenomena that cannot be explained by ordinary substances alone. One example is dark matter. Dark matter, although it cannot be observed directly, existence is inferred from galaxy rotation speeds and galaxy cluster movements. This unknown substance, accounting for about 27% of the mass of the entire universe, it plays an important role in structure formation. Galaxies are important observations in understanding the evolution of the universe. Early galaxies, without the beautiful swirls and ovals of the present, was irregular and chaotic. However, repeated collisions and mergers over time, the structure was in place. These phenomena it is an important factor that astronomers consider when modeling the formation and evolution of galaxies. The structure is formed from surviving gas and dust, but, at the end of its life, releasing the material back into space. Giant explosions and nebula formations. It is part of the process of supplying new elements to the universe. Such a cycle formed a backdrop for next-generation structures and planets. The solar system it is thought to have the best environment in the universe. The reason why the Earth became a planet that harbors life is moderate temperatures and water presence. There is even the protective effect of celestial bodies like the Moon and Jupiter. Having met these conditions, it enabled the birth and evolution of life. In the 21st century, cosmology is evolving further. Gravitational waves and black hole imaging, further high-speed radio bursts, FRB analysis. New discoveries are being made one after another. These studies not only reveal universe mechanisms, it also hints at the state before the Big Bang and the possibility of other universes. As a development beyond the Big Bang theory, a polyuniverse theory was proposed. In this theory, it has been suggested that there may be countless universes beyond our own. These universes may have different physical laws and structures. It provides a new perspective on cosmology. Predicting the future of the universe. This is one of the biggest challenges for astronomers. With observation technology advances, street future scenario, it is becoming possible to consider. For example, exploring the dark ages post-cosmic fuel depletion, and a hypothesis has been made about the state of the black hole after evaporation. In exploring the origin and evolution of the universe, we need to think about our very existence. How the universe was formed, the fact that we're part of it. Philosophy and religion raise deep questions transcending science. Advances in science not only give us the power to understand the universe, such as extraterrestrial life exploration and human space expansion, it's opening up new possibilities. These developments, it would add a new chapter to the epic story of the universe. We, an extremely small being in the vast universe, there is a responsibility to disrupt one's own role and build the future. By knowing the universe's history, it will give us an opportunity to rethink the meaning and direction of our existence. The grand cosmic journey that began with the Big Bang, it's not over yet. From now on, mankind will exploring the unknown universe, I will reveal that secret. The knowledge we gain in it, beyond a mere scientific discovery, it enriches our own evolutionary story. Cosmic microwave background radiation. Further analysis of CMB. It's an important way for us to better understand the early conditions of the universe. This backscattered radiation data, the key to clarifying the expansion rate of the universe and the mechanism of structure formation.
I'm holding it.
With improved observation technology, hitherto unelucidated, new information will come to light. The study of dark matter and dark energy also remains important. This unknown substance and energy, understanding how it is affecting the evolution of the universe as a whole, is one of modern science's greatest challenges. By solving these mysteries, it may provide new insights into the future of the universe. Universe exploration is an adventure pushing humanity's boundaries. The search for extraterrestrial life, the possibility of other planet migration, it shows the future potential of our civilization. Universe is an unknown frontier for us. By challenging it, you can gain new knowledge and hope. Grand tales of the universe inspire our imaginations. It brings a new perspective. In this ever-expanding universe, what we are, what kind of future should we build? The question is, it will continue to challenge us.